Hello, my name is Kunal Hooper. My name is Abhinav Vasudev, and we are going to present you Wireshark software. Wireshark tool is a free and open source packet analyzer, and it is used for networks troubleshooting, analysis, etc. We'll be showing you the stats to submenu of this particular tool.
Under stats submenu, first heading is capture file properties. So capture file properties contains file, time, capture, interfaces and statistics options. Under file, general, it shows the general information about the capture file. And time shows the timestamps when the first and last packets were captured. And regarding capture, it shows information from the time when the capture was done. Interface gives information about the capture interface statistics. It shows the statistics about the network's traffic scene. It consists of display filters. If display filter is set, you will see the values in the capture column, while if any packages are marked, you will see values in the marked column. The values in the captured columns will remain the same as before, while the values in the displayed columns will reflect the values corresponding to the packets shown in the display. Values in the marked column will reflect the values corresponding to the marked packages. Next is the protocol hierarchy. Protocol hierarchy is a tree of all the protocols in the capture. Each row contains of the statistical values of one protocol. It protocol. It shows the protocol's name per percent packets. It shows the percent of protocol packets related to all the packets in the capture. Packets. It shows the number of packets of this protocol, percent bytes. It shows the percentage of protocols bytes related to the total bytes in the capture. Bytes. The total number of bytes of these protocols are shown here. Bits per second. It shows the bandwidth of this protocol related to the capture time. And packets. The absolute number of packets of this protocol where it was the highest protocol in the stack are shown in end packets. And bytes. The absolute number of bytes of this protocol where it was the highest protocol in the stack is shown in the end bytes. N bytes per second. The bandwidth of this protocol related to the capture time when it was highest protocol in the stack is shown in n bytes per second. Next comes the conversation window. It displays the list of conversation between two endpoints, along with addresses, packet counters, and byte counters are also shown here. The follow stream button. The follow stream button will show the stream contents as described. The copy button will copy the values to the clipboard in CSV or YAML format. The graph button will show a graph and the conversation types. From this menu, you can choose the type of traffic tabs as shown.
Next in the menu is the endpoints submenu. The endpoint submenu basically displays a list of endpoints. Endpoints are traffic to from, which is the traffic from to and from an address, and for each supported protocol, a tab. A tab is shown, and in the window, each label shows the number of endpoints that is there in that particular type. For example, Ethernet 84 here means that there are tells that 84 endpoints have been captured during this process of capture. Each row in the list shows the statistical value of the protocol that were captured. The copy button here shows that which format we can copy it in the clipboard, either in CSV or YAML format. The next in the submenu is the input output graph. Here it is a very important part of the statistical portion of this particular tool, and In this graph, basically, we can drag this marker as shown below, and we can use the x-axis of this format of this graph is the time interval or the clicks which by which we can travel, and it shows the time and clicks of the for capture of the packet. And the y-axis can either be unit or the scale. Here basically this graph is a very important part in which we can show how the packet are being captured and what and we can also use time of day or logs, particular log scales, to show and further enhance our understanding of this graph. Copy, as I previously mentioned, can be copied to the clipboard as YAML or CSV format. Next is the service response time. Service response time is the time between the request and the corresponding response. This information is available for many protocols. Service response is basically are currently available for the current four protocols. Some of them are AFP, CAMEL, DCE, etc. I'll be focusing on DCE RPC format. For example, in this type of format, each row corresponds to the method of the interface selected. So EPM format in the previous version has 7 methods, and for each method of the number of calls and the statistics of the SRT, here it is calculated. In this, basically, we can enter any particular display filter, for example TCP. If we apply this particular display filter, it will ease our it will reduce the time amount of time of and amount of packets. The rest of this stats menu is protocol based and can be applied for multiple sources. For example, HTTP packet counter, for example, here it shows the number of HTTP packets, and here each subheading is the shows the particular rate, percent, burst rate, etc. And we can choose display filter also here for the same reason, to reduce the amount of packets. And IPv4 and IPv6 formats are basically, if you select all addresses, that means it will show every address that is the source or destination port of the particular capture of the packets. Same goes for IPv6, all addresses. Here we can also apply destination and ports, which will only capture from the destination for both these formats. And IP protocol types, here we can select the protocol type and the particular packet captured. Here also the display filter is used, for example HTTP. If we apply it, here it is 0. Thank you.